So hello everyone, welcome to our talk today as part of the EAN iBrains joint workshop. My name is Alex Hupton. I'm joined today by my colleague Stefano Guarini. We're both from ETHZ CSCS, and today the topic of our talk is going to be about data safety in the Phoenix infrastructure. So yeah, let's make a start. So what will we talk about today? So we're going to give an overview of Phoenix and also how Phoenix interacts or is part of eBrains. Then we're going to talk specifically about the CSCS Phoenix infrastructure offering. Then we're going to talk about user-defined access control, focusing on the role-based access control. Then we'll look at some examples of how people are making use of the, let's say, the safety features of the infrastructure. And then finally, we're going to finish with a look into the future. So how might this look into the future, specifically focusing on multi-tenancy? So what is Phoenix? So the Phoenix infrastructure is being built by 5 European supercomputing centers, which are BSC in Spain, CEA in France, Cineca in Italy, ETH-CSCS in Lugano, and the Jülich Supercomputing Center in Germany. And the IC project is the first implementation of Phoenix, and it's a project that runs under the umbrella of the HPP. And in essence, it's the 5 supercomputer centers together building a federated infrastructure. So let's have a little bit of a more in-depth look at what Phoenix is. So the slide on the diagram on the right of the slide gives an illustration of the concept of Phoenix. And in essence, the Phoenix infrastructure is providing e-infrastructure services at each of the 5 supercomputing centers that were mentioned in the previous slide. And they are making resources available to different research communities, which includes the neuroscience community, both inside and outside of HPP. The Phoenix resources also form the basis for community-specific tools and services. Specifically in the case of the Human Brain Project, you might be familiar with the eBrains Collaboratory, which is using Phoenix infrastructure services. And as mentioned also before, the Phoenix infrastructure services are also available to other research communities. So it's also offered to European research communities at large. So on the previous slide, it was mentioned that e-infrastructure services are offered to researchers. So what specifically are those? So firstly, we have the interactive computing services, which offers researchers or users quick access to single compute servers to analyze and visualize data in an interactive way, or also to connect to simulations that are already running, which are using the scalable compute services. The scalable compute services are what you might consider your classic HPC systems, your classic supercomputers, which are, for example, in the case of neuroscience, suitable for highly parallel brain simulations or for doing high throughput data analysis tasks. In addition, we also have the virtual machine services, which allow people to deploy virtual machines, VMs, in a stable and controlled environment, which, for example, is suitable for deploying platform services such as the previously mentioned Collaboratory or the neuromorphic computing front-end services. Then we also have the data repository services. In this category, we have the active data repositories, which you can think of as the data repositories that are very, very close to the computational resources, but which are used for temporary storage of data sets. And then we have the archival data repositories, which are the data sets that you want to keep for a longer time. These are typically optimized for capacity, reliability, and availability. And they also allow data to be shared with other users, which might be both inside and outside of the HPP. So now I'm going to hand over to my colleague, Stefano Guarini, and he's going to talk a little bit more about the CSCS specific offering within Phoenix.
Thank you, Alex. So as Alex said, each of the 5 members of the Phoenix infrastructure consortium called Phoenix is basically offering the variety of service that Alex just mentioned. And in order to go then in details for the data safety, we have to see that there are 2 categories of services. One is more HPC oriented. So what, for example, at CSCS we offer is SpeedState. It's our flagship system for HPC computing. we have two flavors of it. One is multi-core, one is hybrid, meaning with GPUs. And these are the machine that any HPC user is typically using to compute science. But for the neuroscience, so under the HPP umbrella, we have been asked some years ago to provide also a different approach in order to help neuroscientists to develop their science and their portal, not only the way you do science, but also the way do you share with colleagues, because that's an important aspect of the scientific, let's say, infrastructure that you have to compute. But in this period, it's important to start sharing, and here comes the security part. So if you look at the lower part of this slide, you can see an offering that is providing VMs, so an OpenStack cluster that is more a cloud approach to provide services and compute services to science. Obviously, it's different. It's no high performance as we used to do, but it's convenient for offering our users a way to manage their own service, because that's the part we will highlight in the slide afterwards, is that we as infrastructure, we are focusing on providing a service to the society and community that are providing services themselves to their users. So it's kind of piling up, but that's what we have to focus on, providing the proper safety. And so here, especially in the storage part, so when we talk about object, we have to talk about how do we segregate and provide the proper segmentation in order to provide the tools for our users. And when I say our user, the user of the infrastructure, to provide the proper tools to implement security and safety. So going more in details, when we talk, for example, about data safety, as infrastructure, we are focusing on providing the proper tool to enable, for example, guys like NRPs that are part in eBrains community and providing services, or the eBrains itself, as Alex mentioned already, to provide a proper service to the user that makes sure that data are not shared if you're not by design. So one tool we are providing to this community is, for example, the role-based access control. That is something that in the usual HPC or POSIX world, we were not able to provide. So this is totally a cloudish technology or way of approaching, let's say, user permission. So if you look at this slide on the left, you have a diagram, an high-level diagram showing how we provide, for example, object storage. So we have a classical GPFS cluster or spectrum scale now that it's provided by IBM. And on top of that, we are able to provide an object interface. So in the case of Phoenix, we decided to go for Swift because it's enabling the federation concept that Alex introduced before as part of the Phoenix infrastructure. So through this tool, you are able to provide object storage, so exactly like Amazon or Google are providing. From an HPC center, now you can save your data and be able to share using this nice protocol. But what you need to make sure is that the permission is properly set. And object storage has this new concept, is role-based access control. So each user can be assigned to a role, as you see on the image on the left, on the right, sorry. And roles goes with authority level and permission to do something. So you are authorized to do or to access. To do means to set permission or revoke permission for other user, or just being a simple user, so you use it, or even just remove any permission and be able to share with the community. And also in that case, you can have another component that is the time. In order to achieve a nice security, you can decide to share this object or file, whatever it is, for a period of time, limiting the security exposure to a time limit that makes sense to the community and accepted by security officer. So going a little bit more in details, what you can do, for example, in the object world with this approach of access control is, so typically in the object world, you have the object itself, that is a file, if you are used to POSIX, and a container that is more similar to the concept of the directory. So at these two levels, you can define who you want to access your object or container or anyway files. And this is all done through RESTful API. RESTful, it's kind of a buzzword, but what does it mean at the end is you have an hook that you can invoke using the web world to set some properties to these, for example, way of controlling access. So everything that we do on the lower part of the schema you saw before, so the cloudish approach is providing RESTful APIs to our user in order to be able to set by themselves the limit where they accept the security to be set in this case, for example. So if you want to have a parallelism, basically in the POSIX was you have ACL, so this access control list, that is already a good tool. But in order to have a more fine-grained control of the who can access your file or your data in general, you have this, basically you add this role on top so that you are not limited of the concept of user, project, group, but you can go directly to the single object and give, okay, this role that can be owned by a group or a user or whoever can do this. So you can basically group your access permission differently. And at the end, you can provide similarly to what you do in POSIX, read, write, or even more advanced. So you can make it all public, as you can do in POSIX, or as I was mentioning before with these temporary URLs. So you can say anyone can access, but we know this is not safe enough. So just for 1 hour, for 1 day, or whatever you want. And this is, and I'm stressing this concept, is who is deciding this is our user. So who is managing a portal in the case of eBrains, for example. So in the object store, obviously you have an additional part that is the metadata part, and these are basically attributes you can connect to your storage. And this is very important, especially in some use case we have in eBrains, like data curators or others that are catalogizing their data more properly so that a tool like the knowledge graph, for example, can take advantage of it. So these are all properties that a user of this Phoenix infrastructure can use to properly archive their data and make accessible to their user in a proper manner. So here there is a link of a documentation of what I'm saying, for example. Take your time and you can click and have a look. Then obviously we have multiple, this slide is just to stress the fact that you can access object storage as you were used before, for example, in POSIX through multiple ways, but you have also the nice web, or let's say more user-friendly way of you doing it. And no matter the way you use or you decide to access your data, the way you define the access will remain the same. So it doesn't change. So going more in detail, I already mentioned some of the usage of this infrastructure, but we wanted to give all of you an example that you have multiple ways. So we are an infrastructure, as I stressed already, and you can have different kind of users. So there is one typology that we are struggling to define at the federation level, but there is, and it exists, and we are declining it. It's a service account, and it's basically a kind of power user that a community like eBrains or whoever can use to build on top of our infrastructure then their own service. And this power user obviously will have access. So it's not providing then the real data security that you can imagine, but this means we are delegating the data security or the data safety to the level of the user of our infrastructure. So eBrains is providing, for example, for the data proxy, an abstraction that before going and touching basically any object is providing a user base by itself and providing a user role-based access control at their level, at the portal level, that we respect, because the service account will act just like the service man in the middle, or the man in the middle, doing the operation that the portal on top is asking to do, and is not touching permission at the higher level. That is the way that eBrains decided to give data safety, for example. And in the same way, knowledge graph works. And if we go to another different approach, just to take also in the loop also the part that is more HPC, like Pitstain. So if you decide to provide a service that combine data and computing, so the way that TVB, for example, is providing it, they do use service account, but they do make a strong use of containerization, provided that CSCS, that is through the Cyrus engine, and the file system encryption in user space level. So again, here we stress the fact that we provide the infrastructure, we give you the tools, but we cannot control what you do at all levels, especially if you are providing a service for others. So in this case, the TVB, what they decided to be safe in managing people's data, and especially data that they know and we don't know as infrastructure. So they decided to go and run their calculation in container that is isolating completely from the environment that we provide, and saving the data in a space that the user can decide to encrypt. And the keys are not shared with the infrastructure. The keys of this encryption is owned by them, so the user of the infrastructure. And this makes sure that us as infrastructure cannot play with that, providing a good level of safety. And a different example then is the data curation or the human data gateway, for example. They decided to make full use of the role-based access control we provide. So not use a service account and not provide a second layer to decide the data safety of their offering, but they rely on the tool we give, and they make the full use of all we discussed before. So going precisely in putting metadata on the data they save on our infrastructure, and defining who can access or not. And they do also make a lot of use of the temporary URL, for example, when they decide to share at the scientific level. So in all the offerings, something we didn't mention is we do have also the long-term preservation of data. And this comes with the concept of PID that is really important for scientific community that decide to share data at an article level. So if you want, you need to have a reference that stays there. CSCS and other people in the Phoenix infrastructure are providing this PID concept. So it's basically a permanent link to your data that you decide to save in an object store, for example, at CSCS. So then looking at to the future, what we wanted to give is what we are working on in order to make what we stressed as isolation and segmentation even to an extreme. So what we are trying to do is what we are doing is building an infrastructure, an IT infrastructure based on microservices in order to allow us to provide multi-tenancies on top of all our offering, including the HPC world, something that at the moment was not possible when we started with the eBrains collaboration. And with these, a lot of the segregation will come by itself, because we will be able to provide our users, so for example, to eBrains, their own tenant, meaning a virtual, let's say, computer room on top of our infrastructure, so that they manage and they are able to provide the safety they want without us really interacting too much. We simply provide hooks. And this is all we wanted to present. So thank you for your attention.